This is my geometry course. Today we're going to learn how to find the coordinates of points of concurrency generated by triangles. If you haven't watched the video from the previous class, review on linear equations, linear graphs, systems of equations, and equations with parentheses, be sure to do that before watching this video. You're going to need to review that material before watching this video so that you can follow along with this class. Also, be sure to finish the homework for the previous class. Remember, if you don't do the homework for these classes, it's a 100% guarantee that you're going to learn absolutely nothing in this entire course. So that said, let's get started. We're going to find the coordinates of the orthocenter, centroid, and circumcenter, but we're not going to find the coordinates of the incenter today. We're going to start by finding the orthocenter of a triangle, but before we do that, we're going to do these problems that are designed to prepare you for the orthocenter problems. So it says, for each problem below, find an equation of the line perpendicular to the segment graphed and running through point P. So they're asking us to find the equation of a line. To find the equation of a line, you need two things: a point on the line and the slope of the line. For example, if you're going to find slope-intercept form, you need the y-intercept, which is a point on the line, and you need the slope of the line. If you're going to find the equation in point-slope form, then again, you need a point on the line, in this case the x and y value, and you need the slope of the line. Well, we already have a point on the line because this problem tells us that our line should be going through point P. So we know point P is on the line. We have our point. We just need to find the slope. So to find the slope of the line we're going to use segment AB. We're going to find the slope of AB because we're looking for a line that's perpendicular to AB. So we're going to find the slope of AB and use that slope to find the slope of a line perpendicular to AB. So we're going to use the slope equation. In case you forgot, that's the general slope equation. And then we're going to find the slope of segment AB using B as the second point. And by the way, we should go ahead and write these coordinates. In some of these problems, I write the coordinates for you, but in other problems, you may have to write them in yourself. And B is going to be 1, 5. And A is going to be -2, -1. So now we're going to find the slope of AB. Again, using B as the second point, we have 5 minus -1. Over 1 minus -2, and then we get 6 over 3, which is 2. And we're going to use that slope, the slope of segment AB, to find the slope of the line that is perpendicular to AB. So that is step 2. The slope of the line perpendicular to AB is just going to be the opposite reciprocal. That's what this information tells us. This is just a fancy way of saying if you want to find the slope of a line that is perpendicular to another line, then you just take that slope of the other line and you flip it and change the sign. So it's positive, so it becomes negative. And 2 is the same thing as 2 over 1. So if you flip it, it should look like 1 over 2. So now we have the slope of our line, and we have, again, the point, a point on the line, P. So now we can just write the final answer, and we're going to use point-slope form because, we have a point and we have the slope. Slope-intercept form is not really going to be useful to us in most of this class. Actually, it would be useful, but for instructional purposes, I'm just going to use point-slope form. So now we're going to plug in the point, which is 5, 4, and then our slope, which we found, our x value, is 5. And that is the answer to that particular problem. So what we did, again, just to be clear here, we found the equation of a line going through point P that is perpendicular to the segment AB. And what that means is if you extend this segment out, the angle between them would be 90 degrees. That's what perpendicular means. That's the definition of perpendicular. There are all kinds of lines that we could draw through point P, all kinds of lines that contain point P. You might draw this line, you might draw this line, you might draw this line. But we don't want just any line. We want a line that goes through point P and is perpendicular to AB. So we had to find the slope of AB and then find the opposite reciprocal of that, and that's the slope of a line that is perpendicular, and then we just plugged in this point, and that made sure that the line went through point P. Again, I know that's a lot to think about, but sometimes in math you got to do some problems that are pretty involved. So all that said, let's now try number 2, one more before you try one on your own. So step 1 is to find the slope of ij, and using j as the second point, we have 1 minus 5 over 4 minus negative 2, which is negative 4 over 6, which simplifies to negative 2/3. So that is the slope of ij. And part 2, we need to find the slope of the line perpendicular to ij. And for that, we just flip this slope and change the sign, so we get positive 3/2. In part 3, we just write the equation that contains this slope and this point here, point P. So y plus 2 equals 3/2 x plus 3. And there you go. So not too bad, just 3 steps on these problems. So I'm gonna leave those problems in the window, and I want you to go ahead and try problem number 3, and when you come back, we'll do it together. All right, we're back. So step number 1, we're going to find the slope of CD. Using D as point 2, we have 2 minus 1 over 2 minus negative 1, and we have 1 over 3. And now we have to find the slope of the line that is perpendicular to CD. And we just switch the sign and flip it over so it becomes 3 over 1, or we can just write it as negative 3. And now we can write the point-slope form of the equation because we have our slope, and up here we already had our point, 1, 7. So y minus 7 equals negative 3 times x minus 1. So if you got that answer, good job. All right, try number 4, and when you come back, we'll do it together. All right, we're back. Step 1, we're going to find the slope of EF. Using f as point 2, we have negative 1 minus 6 over 6 minus 3. And then we get negative 7 over 3. Now we have to find the slope of the line that is perpendicular to EF. So that would be, we change signs and it becomes 3/7. And then we just have to write the equation of our line with the point 2, 2 and the slope 3/7. So y minus 2 equals 3/7 times x minus 2. So if you got that answer, good job. All right, so those problems were preparing us for problems where we're going to find the coordinates of the orthocenter of a triangle. So we have a triangle here, and let's review what the orthocenter is. If you draw, let's say that I make this the base of the triangle. If that's the base, then the height is going to be something like this. Now, let's say that I make this the base of the triangle. Then the height of the triangle is going to be something like this. And by the way, the altitudes are called, or the heights are called altitudes. So that's going to be altitude 2, and the other one we can call altitude 1. And where they intersect, that's going to be the orthocenter. Now I could draw a third altitude. If I make this the base of the triangle, I could draw a third altitude, and that would also go through the orthocenter, of course, but I don't really need to do that. I know that this is the coordinate of the orthocenter because these two altitudes intersect there. I mean, think about it. Why would I need the third one? I know that because we've shown that altitudes of triangles are always concurrent, we only need 2 equations. Now you're probably thinking to yourself, wait a second, can't we just write this coordinate? Well, we could write that coordinate and it would probably be correct, but sometimes the math is not going to be that easy. So you need to learn how to find the coordinates with some more sophisticated methods here. So what we're going to do is we're going to find the equation of the line that contains this altitude, and we're going to find the equation of the line that contains this altitude, and then we're going to solve that system. We're going to make a system with those 2 equations, and we're going to solve it, and the solution is going to be the coordinate where they intersect. Remember, that's one way to solve a system of equations, is by graphing and finding where they intersect. That's the solution of the system. So now we're kind of going backwards. We're solving the system, and then using that coordinate, that answer to see what coordinate the orthocenter, where the intersection point would be. So all that said, let's go ahead and get started. We're going to start with altitude 1, the red altitude. We have to, again, find the equation of the line containing that altitude. So we need a point and we need the slope. So we have a point, that's easy, but we need to find the slope. We know it's perpendicular. The altitude must be perpendicular to AC because that's just the way altitudes work. This angle has to be 90 degrees. Think about it. Every height of a triangle is perpendicular to the base. That's just the way it is. So we're going to find the slope of AC and then use that slope to find the slope of this line, or the line containing that altitude, which is perpendicular to that segment. So step number 1, slope of AC is 1 minus 3 over 4 minus negative 2, and that equals negative 2 over 6, which is negative 1/3. So now we're going to find the slope of a line perpendicular to AC, and that's going to be the slope of the altitude that we're looking for. So that's just going to be the opposite reciprocal, which is just positive 3. So then we're going to do the last step. We're going to write the equation of the line containing that altitude. And notice we have the slope of the line containing this altitude, but we need a point. Well, that point has to be the top of the triangle if we consider this to be the base. So that point is going to be 2, 7. So we have y minus 7 is equal to 3 times x minus 2. And that is the equation of the line containing altitude number 1, the pink altitude. All right, so now we're going to do the same thing with the blue altitude. Step number 1, we're going to find the slope of this segment and then use that slope to find the slope of the blue segment. And then we're going to use this point to write the equation of the line containing that altitude. I know this stuff seems complicated, but these problems are a little bit involved. But these are really, really good problems for you to practice. You're reviewing a lot of different things at once. You're learning or reviewing graphs. You're reviewing forms of linear equations. These are all hugely important parts of the math curriculum and also specifically the geometry curriculum. So step number 1, we're going to find the slope of AB, and that is 7 minus 3 over 2 minus negative 2. And that is 4 over 4, which is 1. And then we're going to find the slope of the line perpendicular to AB, and that's just the negative reciprocal. Now this 1 over here, that can be written as 1 over 1. So you see if we flip it, you just get 1 over 1 again, so it'd just be 1, but you do have to change the sign. And lastly, we're going to write the equation of the line. So again, we're using point C, so y minus 1 is equal to negative 1 times x minus 4. And that is the equation of the line containing altitude 2. The equation of this line. So again, we used this point because we need two things to write the equation of a line. A point on the line, in this case C, and the slope of the line, which we found by analyzing the slope of AB. All right, so now we're going to use those two equations to find the intersection point. So we're going to write a system of equations using those two blue equations that are highlighted. Then we're going to solve that system of equations, and that's going to be this coordinate. It looks like the coordinate is going to be 1, 2, 3, 4. It's going to be 1, 4. So we should get 1, 4 in our answer. Now again, I know what you're thinking. You're thinking, this is ridiculous. Why are we doing this? We can see what the answer is. Well, no, you really can't rely on that, because what if that point is actually a little bit off? What if it's over here? And there's also cases where you're going to have problems where it's not easy to see the point of intersection. So I'm just choosing this point right on that corner just because it makes the numbers easier. But you still have to learn these complicated methods to find that coordinate. You can't just assume it's there, unfortunately. So I'm going to, just like we did in the previous class, I'm going to solve this system of equations, and that's going to give us that special coordinate right there, which is the coordinate of the orthocenter, and that's the whole point of what we're doing. So I'm going to isolate y in the top equation. So I added 7 to both sides, and I'm just going to rewrite the bottom equation. I'm going to rewrite the bottom equation, but instead of putting y, I'm going to put what the top equation tells us y equals. So again, I took what y equals and I plugged it in here. So then I'm going to get rid of the parentheses because we have an equation with parentheses. So 3 times x is 3x, 3 times negative 2 is negative 6. And this is just considered negative 1. Negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. So I'm not going to do all this with you because this is all just basic math. If you do all that math, you're going to end up with x is equal to 1. So then we need to find the y value. So we're going to go up here. And I'm going to take the equation where y is solved for and rewrite it just like we did in the previous class. And I'm going to plug in what x equals and then just solve, and we get 4. So the coordinate of the orthocenter is 1, 4. And that's what we expected. So that's the final answer. So I know that seems like a lot, but these problems are just really, really good for you to review linear equations and also to remember the points of concurrency generated by triangles. So let's do another one of those together before you try one on your own. I'm going to consider this side to be the base. So that would mean that this would be an altitude. And I'm going to consider this to be the base. Then the corresponding altitude would be like so. So I'm going to mark that altitude 1 and altitude 2. So we're going to find the equation of the line containing altitude 1 first. So we have to find the slope of AB, the slope of the base segment. And that's going to be, using B as the second point, we have 2 minus 1 over 4 minus negative 3. And that's going to be 1 over 7. Then we're going to find the slope of the perpendicular line. So the slope of the perpendicular line is just going to be the negative reciprocal, so that would be negative 7, or the opposite reciprocal. And then we're going to write the equation of the line, and the pink line contains point C, so we just write y plus 4 is equal to negative 7 times x minus 2. And that is the equation of the line containing altitude 1. So now we're going to do the same thing with altitude 2, but we're going to consider AC to be the base, so we have to find the slope of AC. Considering C to be the second point, we have negative 4 minus 1 over 2 minus negative 3. And we have negative 5 over 5, which is negative 1. So that is step number 1. And step number 2, we're going to find the slope of the line perpendicular to AC. And that would just be positive 1. And last step, we're going to find the equation of the line containing altitude 2. So that is y, for altitude 2, point B is on the altitude, so we have y minus 2 equals 1 times x minus 4. So that is the second equation that we're going to use to find the orthocenter. And then we're just going to find that point of intersection. Now here's a good example where the point of intersection doesn't happen on the corner of a square. So how do you find it? Well, you certainly don't estimate it. You're probably thinking, well, it would just be 3 halves and maybe negative 1. That might work. That might be the correct answer, but it might not. So that's why you have to do all this stuff. You have to do the algebra to be sure. So now to find the point of intersection, we're going to write a system of equations. We're going to rewrite the top equation, the top blue equation, and the bottom blue equation. And then we're going to, just like in the previous class, we're going to isolate the y value in the top equation and rewrite the bottom equation. And then we're going to take the equation where y is not isolated and we're going to rewrite it. But we're going to take all this stuff and plug it in for y. So now all we have to do is solve this equation with parentheses. We're going to use the distribution rule. Negative 7 times x is negative 7x. Negative 7 times negative 2 is positive 14. 1 times x is x. 1 times negative 4 is negative 4. Then we're just going to simplify all this. It looks like we get 3 halves. So now we're going to take the equation where y is solved for and use that to find y. So y is equal to negative 7 times, and we can plug in the x value that we just found. So now we just have to crunch all these numbers, do all this math. 2 is the same thing as 2 over 1. Multiply both sides by 2, and you get 4 over 2. Now we have a common denominator. So it's 3 halves minus 4 halves. We're using PEMDAS, doing the parentheses first. 3 halves minus 4 halves is negative 1 half. So the parentheses becomes negative 1 half. Then you multiply negative 1 half times 7. 7 is the same thing as 7 over 1. So we have negative 7 over 1 times negative 1/2. Negative times negative is a positive. 7 times 1, 1 times 2, we get 7 over 2. So these are all things that you should have learned in my arithmetic course. Then you get 7 over 2 minus 4. Write 4 over 1, multiply both sides by 2, and you get a common denominator. Now we have 7 over 2 minus 8 over 2. And that is just negative 1/2. So all of that simplifies to negative 1/2. So I know you don't like those fractions. I know you don't want to do those. But they're just part of the math curriculum. You're just going to have to get used to doing all the math with arithmetic and using PEMDAS. Now, if you're rusty on that stuff, you can go online and do some practice problems with PEMDAS, or you can do some practice problems with fractions, or you can go to my arithmetic course. But we don't have time to go over that stuff in more detail. In fact, that's pretty much all I'm going to explain. I'm going to require you to do the arithmetic on your own. This is not an arithmetic course. This is an algebra course and a geometry course. So now we have the point of intersection. So we can say the orthocenter is at 3/2, negative 1/2. And that is the final answer. So in that case, we had some fractions. It looks like 3/2 and negative 1/2. That makes sense. So right about there. All right, so why don't you go ahead and take a screenshot of those problems, because you're going to do one on your own now. For number 7, you're going to go ahead and try that one on your own. Now be aware that you can use, there's 3 altitudes that you can work with. Now sometimes you may get a fraction when you're finding the slope of the altitude. So you want to try to stay away from those if you can. So I'm going to show you what altitudes I'm going to use so you can follow along. I'm going to use, let's see here, I'm going to use this altitude. Notice the altitude is now outside the triangle. So that means we're considering this to be the base. This would be the altitude, if that's the base. Something like that. It's not exactly correct, but so that's altitude 1. And for the second altitude, I'm going to consider this to be the base. So this would be the other altitude. But if you extend those lines out, the orthocenter is going to be somewhere up there where they intersect. So that's altitude 2. So go ahead and attempt that problem. And you want to probably use those altitudes just so you can follow along with me. That line is really not straight, as you can see, but you get the point. So try number 7, and when you come back, we'll do it together. All right, we're back. We're going to find the equation containing altitude 1 first. So we need to find the slope of AB, and that would be, considering B to be the second point, we have 2 minus negative 4 over 1 minus negative 5, and we get 6 over 6, which is positive 1. And step 2, we need to find the slope of the perpendicular line, which would be negative 1. And step number 3, we can now write the point slope form of the equation containing that pink altitude. By the way, I extended these altitudes out so you could see where they would cross, but the altitudes actually only go this far. They have to stop at the base. Just be aware of that. So there's a difference between the altitude and the line containing the altitude. So now for altitude 1, point C is on that line. So we're going to use point C, y minus 0 is equal to negative 1 times x minus 7. And there you go. So that's the equation of the line containing altitude 1. Now we have to find the equation of the line containing altitude 2. So step 1, this is the base, the corresponding base for altitude 2. So we have to find the slope of AC, and that is 0 minus negative 4 over 7 minus negative 5. That would be 4 over 12, which is 1/3. All right, and now we have to find the slope of the line perpendicular to AC, and that would just be -3. And now we can write the equation of the line containing altitude 2, and of course B goes through altitude 2, so y minus 2 is equal to -3 times x minus 1. So again, if you used altitude 1 and altitude 2, then you should have those equations. Now if you consider this to be the base, then this is going to be your equation, something like that. And it should be touching, if I draw it correctly, perpendicular to that base, it should be somewhere around that intersection point, because again, these lines are concurrent. They must cross at the same point. So now we're going to come up with a system of equations to find that intersection point. So we're going to rewrite those blue equations. My computer's doing weird things, so I'm sorry that's kind of messy. All right, now we're just going to get rid of that 0 because y minus 0 is just y. So y is now solved for in the top equation, and we're going to use the substitution method like we did in the previous class. We're going to take the second equation and we're going to rewrite it, except instead of y, we're going to write what the top equation tells us y equals. And now we just have an equation with parentheses. So first thing to do is get rid of the parentheses. -1 times x is -x. -1 times -7 is +7. -3 times x is -3x. -3 times -1 is +3. And now we're just going to solve that equation. So we get -2 is equal to 2x, and x is obviously just equal to -1. So now we take the equation where y is solved for, and we use that to find the y value by just plugging in the x value we just found. And thankfully the math on that is pretty easy. We just get +8 because -1 minus 7 is -8, and then we get a double negative, which just becomes a positive. So the orthocenter, or the coordinates of the orthocenter, are -1 and +8. So if you got that answer, good job. So let's see if that makes sense. Let's see if -1, 8 is roughly in the right place. So -1, 8, 1, 2, 3, 4, 5, 6, 7, 8. So it should be there. It's roughly in the same spot, but again, you can see that our graph needs to be perfectly precise in order for this to work. So that's why we have to do this math in order to make sure that we have the right answer. So now, why don't you try number 8? Let me show you the altitudes I'm going to be using. I'm going to consider this to be the base, so this will be an altitude. Doesn't have to be perfect, so that's altitude 1. And I'm going to consider this to be the base. So if that's the base, then this would be altitude 2, or the line containing altitude 2. So our intersection point should be somewhere up here. It's actually off the graph. So that's another reason that you want to use this math. So that's altitude 2. So go ahead and try number 8. I'm going to leave number 7 in the window. And when you come back, we'll do it together. All right, we're back. So step 1 is to find the slope. AB is considered to be the base in this case. So we're going to find the slope of AB. Considering B to be the second point, we have 4 minus 6 over -5 minus -3. And that is -2 over -2, which is +1. So now, that was step 1. Now we have to find the slope of the line perpendicular to AB. That's just going to be -1. Just flip this, which remains the same, change the sign. And the corresponding point would be C, or the point on the line will be c, so y minus 2 is equal to negative 1 times x minus 5. So that's the equation of the line containing altitude 1. And now we're going to do the same thing for altitude 2. The corresponding base for altitude 2 is AC. So we're going to find the slope of AC. Using c as 0.2, we have 2 minus 6 over 5 minus negative 3. And we have negative 4 over 8, which becomes negative 1/2. So now we have to find the slope of the line perpendicular to AC. That would just be the opposite reciprocal, which is 2. Now we just write the equation of the line containing altitude 2. And for altitude 2, point B is on the line. So it would be y minus 4 is equal to 2 times x plus 5. And that is the equation of the line containing altitude 2. So now we're ready for intersection points, or the one intersection point. We're going to rewrite the top blue equation, and we're going to write the bottom blue equation, and then we're going to isolate. We're going to use substitution, but before we use substitution, we have to isolate the y in one of the equations. So I'm going to isolate it in the top equation, and then just rewrite the bottom equation. And now I'm going to take the equation where y is not isolated and rewrite that, but instead of y, I'm going to plug in what the top equation tells us y equals. Now I have an equation with parentheses. I just have to get rid of the parentheses and solve the equation. So we have negative x plus 5, so on and so forth. Looks like if we solve this equation, we have negative 7/3. So now we're going to take the equation where y is solved for and use that to find y. Because we have a fraction, this is probably not going to be easy as far as the arithmetic goes. But again, that's just a fact of life in math. You have to use arithmetic. That's why that's a prerequisite for this course. So we rewrote that equation and plugged in what we know x equals. And now we just have to do the math. So negative 7/3 minus 5 would be negative 22/3. And this negative out here it makes it a double negative, so it become positive 22/3. And then we have 22/3 plus 2. That would be 22/3 plus 6/3 is 28/3. So y is equal to 28/3. Again, if you're having problems with that, just do practice problems with order of operations and also fractions. So now we have the coordinate, or the coordinates of the orthocenter. I suspect probably the hardest part of that for a lot of students these days is just doing the arithmetic, because students are so deficient when it comes to basic arithmetic. That's usually the biggest problem that they have in algebra these days. But if you got that answer, good job. All right, so now we're going to do some easier problems. You're probably glad to hear that, because those problems seemed like they were probably pretty challenging. Here we have vertical lines, or one vertical segment, and we have a horizontal segment. So what that means is if you were to place this triangle so that this is the base, then the height of the triangle would just be this side of the triangle. So that's one altitude. So that would be altitude 1. And if you were to make this the base, then the height of the triangle would be this side of the triangle. That's altitude 2. So because those are the altitudes, you can obviously see that the intersection point is actually one of the vertices of the triangle. So we don't have to do anything with this problem. We can see that the orthocenter is just point B, which is -3, -3. So that is the answer. So that is true of any right triangle. This is actually a right triangle because this is a vertical line and this is a horizontal. The angle between them, just by definition, the angle between them is 90 degrees. So for any right triangle, the orthocenter is always at the vertex next to the 90-degree angle. So why don't you try number 10? It's going to be a pretty quick problem, if you know what I mean. And when you come back, we'll do it together. All right, we're back. So the orthocenter is 1, 2, 3, 4, 1, 2, 3. So 4, 3. So again, that's a very easy problem. So if you got 4, 3, good job. Because that is the vertex of the triangle that is next to the 90-degree angle. So now we're going to move away from the orthocenter, and now we're going to work on finding the centroid of a triangle. But we're going to do some practice problems before we do that. Just to warm up here. It says find an equation of the line that runs through point Q and the midpoint of the segment shown. So again, we're looking for the equation of a line. That's the most important thing to understand about these problems. We're looking for an equation of a line. In order to find the equation of the line, you need two things: a point on the line and the slope of the line. So we already have a point on the line because we know that the problem tells us that our line is going to run right through point Q. So we already have a point on the line. We just need the slope of the line. Now, the line says that we're going to run through the midpoint of this segment, so our line is going to look something like this. And if we can find that midpoint, then we'll have 2 points. And if we have 2 points, we can find the slope using our equation y2 minus y1 over x2 minus x1. So that's what we're going to do. But we can't do any of that unless we find the midpoint of AB first. Again, I know this seems like it's really complicated, but this is all stuff that you need to be able to do. So we're kind of jumping it up a notch from my beginning algebra course with this this type of geometry and graphing linear equations, or writing equations of lines. So step 1 is to find the midpoint of AB. Now this is the midpoint equation. You can get a screenshot of that if you want, but I'm going to go ahead and write it here just to show you what equation I'm using, or what formulas. So that's the formula I'm going to use to find the midpoint. And we want the midpoint of AB, or the midpoint between AB, so we're going to add the x values together. And that's the x, and divide by 2, that's the x value of the midpoint. And then we're going to add the y values together and divide by 2, and that's the y value of the midpoint. So the midpoint between A and B, if we do all the math on that, we get 1 and 0. So that's the midpoint between A and B. So we have the midpoint, and so we have 2 points on our line. Again, our line goes through the midpoint and Q. So now we have 2 points. We have the midpoint and we have Q. So that means that we can find the slope of the line. So the slope, this is part 2, the slope of the line containing the midpoint, I'm just going to write capital M for midpoint there. The midpoint and Q, the slope of the line containing M and Q, using Q as the second point, is 3 minus 0 over -4 minus 1. So that is 3 over -5. Now, please be aware that we're not finding perpendicular lines, so we're not going to flip this anymore. Okay, all we're doing is finding the line that goes, equation of the line that goes through those 2 points. We're not finding the equation of the line that's perpendicular to this segment. So we're not going to be flipping anything and changing the sign or any of that. So anyway, now we have a point on the line and the slope of the line. So now we can write the point-slope form. And we can use either point. We can either use Q or we can use the midpoint. So I'm going to use Q. So we have y minus 3 is equal to that slope we found, negative 3/5, times x plus 4. And that is the answer. All right, so let's try one more of those before you try one on your own. Step 1, we're going to find the midpoint between C and D. So we're going to add the x values and divide by 2, and add the y values and divide by 2. And then we get 1 and 2, it looks like. 1 and 2, that's right. And now step 2, we're going to find the slope of the line containing that midpoint and Q. So considering Q to be the second point, we have 7 minus 2 over 4 minus 1, which is 5 over 3. And I'm sorry my writing is so sloppy here, but for some reason this program is doing weird things. So now we have a slope of the line that we're looking for, and again we're looking for this line going through Q in the midpoint of the segment. We have the slope of the line, and we have 2 points to choose from. I'm just going to choose Q, so y minus 7 is equal to 5/3 times x minus 4, and that is the answer. Now again, we could use this as our point instead of Q, but it's either answer would be fine. So why don't you go ahead and take a screenshot of all that, because you're going to try a problem on your own now. So go ahead and try number 13. And remember, we're not flipping anything. Notice I didn't take this slope and flip it. I didn't change the sign, I didn't flip it. So we're not doing opposite reciprocals in these problems. So try number 13, and when you come back, we'll do it together. All right, we're back. Step 1 is to find the midpoint between E and F. And so we have negative 2 plus 2 over 2, and 3 plus 5 over 2. And we get 0 and 4. And so the second step is to find the slope of the line containing that midpoint we just found, and Q. And using Q as the second point, we have 5 minus 4. 5 minus 4 over 5 minus 0, which equals 1 over 5. Now, please understand, we're not going to be flipping things. We're not going to be flipping this that fraction, because we're not looking for opposite reciprocals. We're not doing perpendicular lines right now. So now we have 2 points on the median, or the line containing the median, and we have the slope of the line containing the median. So we can write the equation, and I'm going to use Q as our point, so y minus 5 is equal to the slope we just found times x minus 5. And that is an equation of the line going through Q and the midpoint of EF. So if you got that answer, good job. Go ahead and try number 14. I'm going to keep 13 in the window, and when you come back, we'll do it together. All right, we're back. So we're going to find the midpoint between G h, or the midpoint of GH. So we have negative 4 plus 4 over 2, and 7 plus negative 1 over 2, and that equals 0, 3. So 0, 3. And step 2, we're going to find the slope containing the midpoint and Q. So that, using Q as the second point, we have negative 2 minus 3 over 1 minus 0. And so we have negative 5 over 1, which is just negative 5. So now, third step, we're going to find the equation of the line containing the midpoint and Q. So I'm going to use Q as the point, and the slope we just found is negative 5. Again, there's no opposite reciprocal, we don't have to flip it, and x minus 1. So if you got that answer, good job. So now we're going to use the knowledge that we just attained to find the coordinates of the centroid of a triangle. So we're going to draw two medians, just to give you an idea of what's going on here. I'm going to draw this median here, and I'm going to draw this median, and the point we're looking for is here, the centroid. So we're going to find the equation of the line containing this median and the equation of the line containing this median, and then we're just going to find the intersection point using a system of equations, just like we did with the orthocenter problem. So this problem is very similar to one of the problems that there are the four problems we already did. First, we're going to find the well, let's go ahead and label those. So this is median 1, and the blue one is median 2. So we're going to find the equation of the line containing median 1 first. And the first thing we have to do is find the midpoint, because we know that it goes through, we know this, the red line goes through B and the midpoint of the opposite side, but we have to find that midpoint. That midpoint is going to be the midpoint of AC, which equals 1, 2. And step 2, so now we have 2 points on that line. We're looking for the equation of the line. We have 2 points, one here and one here, on that line. So now we can use those 2 points to find the slope of the line containing the median. So this is the slope of the line containing the midpoint we just found, and B, because the red line goes right through B. So using B as the second point, we have 7 minus 2 over 2 minus 1. And that would be 5 over 1, which is 5. All right, so third step. Now we can just write the equation of the line containing median 1. So using B as one of our points, we're going to use point slope form with B as our point. We have y minus 7 equals the slope we just found times x minus 2. And that is the equation of the line containing median number 1. So now we're going to do the same thing for the line containing median 2. So we have to find the midpoint of AB. So the midpoint of AB would be negative 2 plus 2 divided by 2, 3 plus 7 divided by 2, and we have 0 and 5. So now, second step, we're going to find the slope of of that line. So we have 2 points now. We have that midpoint, and we know, of course, C goes through the median 2. So we have 2 points, the midpoint and C. So we're going to find the slope of the line containing the midpoint and C. So using C as a second point, we have 1 minus 5, 4 minus 0. So that becomes negative 4 over 4, which is negative 1. So now we can write the equation of the line in point-slope form because we have the slope and we have not just 1 point, but we have 2 points. So I'm going to use point C. So we have y minus 1 is equal to negative 1 times x minus 4. And that looks right. So that's the equation of the line containing median 2. So now the process is just like what we did in the previous problems. We're just going to write a system of equations and solve it to find the coordinates of the centroid. So now we're going to solve for y in one of the equations. I always do the top equation, or I try to do the top equation, but you can do the bottom one also. And just rewrite the bottom equation. And now I'm going to take the equation where y is not solved for, and I'm going to rewrite it, but instead of y, I'm going to plug in what the top equation tells us y equals. So now all we have to do is solve this equation, and we're going to get rid of the parentheses first. So we use the distribution rule. 5 times x is 5x, and 5 times negative 2 is negative 10. And this is just considered to be negative 1, so negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. So if we combine all this, we have negative 10 plus 7 is negative 3. Negative 3 minus 1 is negative 4. If we solve that, we get 4/3. Looks like x is going to be 4/3. Again, I'm not going to solve that for you right now, just for time's sake, and also because that's really a pre-algebra problem. We did that in my pre-algebra course, so you should be able to do that on your own. And if you can't do it on your own, then that's okay. You just go back into my pre-algebra course, and you can go over that stuff again. So now we're going to take the equation where y is solved for and use that to find y. So y is equal to 5 times x, but instead of x, we're going to plug in 4/3. And now we're just going to crunch those numbers. That's 2 over 1. So multiplying both sides of that fraction by 3, we get 6 over 3. So 4 over 3 minus 6 over 3 is negative 2 over 3. 5 times negative 2/3 is negative 10/3. Looks like we're going to get negative 11/3. We need a common denominator here, multiply both sides by 3, so on and so forth. Again, that's all stuff that you should know already. Actually, that should be positive 11/3. Sorry about that. Positive 11/3. And so the coordinate of the centroid is 4/3, 11/3. All right, so now let's do another one of those problems before you try one on your own. Let's see, it'd be easiest to find this median. We'll call that median 1. And this median here, I'll draw that a little straighter. We can see what the midpoints are just by looking at this triangle, really. Because this triangle has vertical and horizontal sides, we can see what the medians are. I'm going to make red number 1, try to keep blue number 2 so that we don't get confused. So we can see what the midpoints are. We can kind of just skip forward on that. So I'm going to start with median 1 as always. So the midpoint between B and C is that'll be 1, negative 3. So again, we can just see that because it's a horizontal line. And that's step number 1. And step number 2, whoops, I'm on the wrong thing here, sorry about that. Step number 2, we're going to find the slope containing A or containing the midpoint we just found, and a. Using a as 0.2, we have 3 minus negative 3 over negative 3 minus 1. So that would be 6 over negative 4, which is negative 3/2. And now we can just write the equation of that line. Using a, we have y minus 3 is equal to negative 3/2 times x plus 3. That looks right. So that is the equation of the line containing the median number 1. Now we just do the same thing for median number 2. We can see the midpoint. The midpoint is obviously there. So that is negative 3, 0. So the midpoint of AB is negative 3, 0. And step number 2, we're just going to find the slope of the line containing the midpoint. And you can see the median 2 is going through C, so the midpoint in C. Using C as the second point, we have negative 3 minus 0 over 5 minus negative 3, which is negative 3 over 8. So now we can find the equation of the line containing the midpoint and point C. So I'm going to use point C. We have y plus 3 is equal to the slope we just found times x minus 5, again using point C. All right, so now we're going to find the intersection points, rewriting the top equation and the bottom equation. And now you can see we have some really bad news because we have fractions in both equations. But again, this is just something that you can't avoid. If you know how to use fractions, this really isn't that bad. But if you're struggling with fractions, this is going to be a nightmare for you. But again, if you are struggling, I suggest you just review your fractions. This is not something that you can sidestep. You have to know the fractions. So as usual, in the top equation, I'm going to isolate y, and then just rewrite the bottom equation. And then I'm going to rewrite the equation where y is not isolated, but instead of y, I'm going to plug in what y equals. And we're going to go ahead and distribute, get rid of the parentheses, so we have negative 3/2 x, and negative 3/2 times 3 is negative 9/2, and plus 3 equals negative 3/8 x, and positive 15 over 8. Now I'm just going to combine all these numbers. So that would be 3/2, it looks like. Let's see, we have common denominators, so that's good news. So we can just add these together. This, you can put the x up there so it becomes negative 3x. So we have negative 3x plus 3 over 2. We're just combining the fractions because we have a common denominator. So now we're going to take this up here. And we're going to have to multiply both sides of this equation by 4 because we need the denominators on both sides of the equation to be the same. So we're going to multiply both those by 4. I'm going to go ahead and just copy this. So multiply both sides by 4. And you got to use parentheses on that. So we're going to have to use distribution on the top. 4 times negative 3x is negative 12x. And 4 times 3 is 12. And of course we have 8. 4 times 2 is 8 in the bottom. And so now because the equations are the fractions are equal, these fractions are equal and the denominators are the same, we can just get rid of the denominators. The numerators have to be equal. Looks like we get negative 1/3. So now we have to take the equation where y is solved for, and we have to use that equation to find y. So y is equal to negative 3/2, and we'll plug in the x value. That looks all right. And negative 1/3 plus 3, that would be 8/3. 8/3 times negative 3/2 is negative 4. Negative 4 plus 3 is negative 1. So y equals negative 1. And the coordinate of the centroid is negative 1/3 and negative 1. So again, I know that's a lot to think about, but there's no avoiding all that arithmetic. So you can see negative 1/3, negative 1, that's about where our centroid should be. If we go out negative 1/3 and then negative 1, it's right about there. So it looks like I got lucky with my medians there. They're pretty accurate. All right, for number 17, I'm going to use, let's see, it looks like this median here, and also this median. Looks like that'll work well. So we'll call this median 1 and median 2. So those are the medians that I'm going to use. So it's probably best to stick with those. Now be aware that because this is a horizontal line, you can just see the midpoint just by looking at it. It's right there, so you don't have to use the midpoint formulas. Same thing with this vertical line. The midpoint is here, so you can just write that midpoint. You don't have to write the formulas. So I'm going to leave 16 in the window and go ahead and try number 17 using those medians. And when you come back, we'll do it together. All right, we're back. So I can see the the midpoint of BC just by looking at that. Looks like it's 4, 0. Now we just have to find the slope of the line containing the midpoint we just found. And A, using A as 0.2, we have 3 minus 0 over negative 2 minus 4. And that simplifies to 3 over negative 6, which is negative 1/2. So now we can write the equation of the line. I'm going to use point A, so we have y minus 3 is equal to negative 1/2 times x plus 2. So again, we're not flipping anything or using the opposite reciprocal. So that is the equation of the line containing median 1. So now we're going to find the equation of the line containing median 2. So the first thing we do is find the midpoint between A and B, and we can see that midpoint. We can see that it's going to be 1, 3. It's very easy to see because it's a horizontal line. So now step 2, we're going to find the slope of the line containing the midpoint we just found, and point C, because point C goes through the blue line. And so that would be, using C as the second point, we have negative 3 minus 3 over 4 minus 1, which is negative 6 over 3, which is negative 2. So now we can write the equation using point C. We have y plus 3 is equal to negative 2 times x minus 4. And that is the equation of the line containing median 2. So now, to find the intersection points, we're going to use a system of equations using those blue equations that we just found. As usual, we're going to isolate y in one of the equations. And then we're going to take the equation where y is not isolated, and we're going to rewrite it. But instead of y, we're going to plug in what the top equation tells us y equals. And now we're going to use the distribution rule. Negative 1/2 times 2 is negative 1. Again, if you're having trouble with that, you can just review my arithmetic course on the fractions part. I'm going to add all these together, so that would be 5. And now we have an equation with fractions. And there's a number of ways we can do this, but in this case, probably the easiest way to do it. Well, I'm just gonna get a common denominator in all of these. These numbers all have a denominator of 1. So I want a common denominator of 2, so I'm going to multiply both sides of 2 to each of those fractions with 1 in the denominator. And we get negative 8x over 2 and 16 over 2. And, whoops, that should be negative 4x over 2. That looks right. And then now that we have a common denominator, we can add the fractions together, combine them. Yeah, this is just the easiest way for students to understand these problems. And then we're going to go up here. And because those fractions are equal and they have the same denominator, we know the numerators must be equal. Now be sure you understand this negative goes with that x. It doesn't go outside here. That's a huge source of problems. So we're just going to set the numerators equal to each other and add 4x to both sides, subtract 10 from both sides, and we get x is equal to 2. And so now to find y, we just take the equation where y is solved for and rewrite it, and we have negative 1/2. We plug in 2 for x. And we do the math on that, and we get y is equal to 1. So the coordinate of the centroid is equal to 2, 1. So if you got that answer, good job. If you didn't get that answer, that's okay. Just look at the work we did here and go back and figure out what you did wrong. Now let's see if that makes sense. 2, 1, we go out 2 and up 1, and it looks like that makes sense. If your centroid is out here, then obviously we did something wrong. So I'm going to have you try one more of those. Again, you're finding the coordinates of the centroid, and so you can follow along with me. I'm going to have you find the equation of this median and this median. And so we're going to call this, and by the way, it would probably be easier to use this median because it ends up being a vertical line, but we're just going to stay away from the vertical lines just to keep things consistent. So as usual, we're going to call the red median median 1 and the blue median median 2. So go ahead and try number 18, and when you come back, we'll do it together. All right, we're back. So first we're going to find the equation of the line containing median 1. So we first have to find the midpoint of BC, and we're just going to add the x values, divide by 2, and add the y values and divide by 2. and we get 4, 1. Now we're going to find the slope of the line containing the midpoint we just found, and A. And considering A to be the second point, we have -4 minus 1 over -5 minus 4. So again, we're using this point, and we're using point A to find that slope. So that's where those numbers came from. So -4 minus 1 and -5 minus 4. And we get -5 over -9, which is positive 5/9. All right, and now we can just write the equation of the median. And I forgot to number those. So step number 3, we have we can use either point. I'm going to use point A, and obviously the slope we just found, so y plus 4 is equal to the slope we just found times x plus 5, and that is the equation of the line containing median 1, the red median down there. Now we're going to find the equation of the line containing median 2. So we're just going to do the same thing. Step 1, we're going to find the midpoint between A, B, because that's the point where the median bisects. That's the segment it bisects. So midpoint of AB is 1 plus -5 over 2, and 2 plus -4 over 2. And that just equals, I guess I can put it down here. So the midpoint between AB is equal to -2 and -1. So step 2 is to find the slope of the line containing that median, and we have 2 points. We have point C and we have the midpoint we just found. Those 2 points are on that line containing the median, so we can use those 2 points to find the slope. So we want to find the slope of the line containing the midpoint we just found and C. So using point C as the second point, we have 0 minus -1 over 7 minus -2. And then we get 1 over 9. So now we're just going to write the equation of the line containing those 2 points, because now we have the slope. So I'm going to use point C, so we have y minus 0 is equal to the slope we just found times x minus 7, and that is the equation of the line containing median number 2. So now, as usual, we're just going to write a system of equations using the 2 equations we just found. And in the bottom equation, we already kind of have y solved for. In all the problems we've done so far, we always solve for y in the top equation, but because we have a y minus 0 in the bottom equation, I'm just going to solve for y in the bottom equation. Let's see here, make sure we got all that right. When you're doing this amount of work, it's really important to make sure that you do every step correctly, because it's so easy to make a mistake in math. So now we're going to rewrite the equation where y is not solved for, but instead of y, we're going to plug in what the bottom equation tells us y equals. So we have 1/9 x minus 7, we're plugging that in for y, plus 4 equals 5/9 times x plus 5. And now we just have to solve that equation. 1/9 times x is 1/9 x. 1/9 times -7 is -7/9. If you have trouble with that arithmetic, again, you just need to go back and review arithmetic. 5/9 times x is 5/9 x. 5/9 times 5 is 25/9. So This is good news because almost all of these terms have common denominators, but looks like the 4, it has a denominator of 1 because any whole number always has a denominator of 1. Remember that. So we just need to get a 9 under the 4 because in order to solve an equation with fractions, you need common denominators. So I can't just put a 9 under there, though. It's 4 over 1. So I'm going to multiply both sides of this fraction by 9. So we have 36 ninths minus 7 ninths is 29 ninths. And I'm going to go ahead and put the x's in the numerators just to make things obvious. So we have 5x over 9 plus 25 over 9. And I'm going to make this x over 9. Remember, when you multiply a whole number into a fraction, you just multiply the whole number into the numerator of the fraction, and the denominator stays the same. All right, so now, because these all have common denominators, we can go ahead and combine them. Everything looks right there. So now we're going to go up, and because these fractions are equal, and the denominators are the same, that means that the numerators must be equal, and we can just get rid of those denominators. And if we do the math on that, we get x is equal to 1. So now we're going to use the equation where y was solved for to find y. So we have y is equal to, and we just plug in what we just found x equals. X equals 1. So we just have to do the arithmetic here. And again, I know a lot of students are going to be having trouble with the arithmetic, but again, this is all review stuff. You're expected to pretty much have arithmetic mastered by the time you get into this course. If you're rusty on it, that's okay, but if you're completely lost, that's not a good sign. All right, so PEMDAS tells us to do parentheses first. 1 minus 7 is negative 6. And then 1/9 times negative 6 is negative 6 ninths, but we're not done yet because we can reduce that, divide both sides by 3, and we get y is equal to negative 2/3. So now the centroid is 1, negative 2/3. So if you got that answer, good job. All right. On to number 19. We're moving away from the centroid problems now, and we're going to circumcenter problems. But before we do circumcenter problems, we're going to have to do a few practice problems. It says here, for the problems below, find an equation of the line which is a perpendicular bisector of the segment graphed. So we want an equation of the line that is a perpendicular bisector. That means it has to go through the midpoint, and it has to be perpendicular. So it has to go through the midpoint, and this has to be a 90-degree angle. So these problems are going to be, well, let's just go ahead and do it. So step 1, we need to find the midpoint, because remember, to find the equation of a line, we need a point. In this case, it's going to be the midpoint, and we need the slope. We can find the slope of AB to find the slope of the line that we're looking for. That's going to help us find the slope of the line we're looking for. So we'll find the midpoint first. So the midpoint of AB, and we have to write the coordinates in first. There's no coordinates here. So that would be negative 3, 6, and B is 3, 3. So negative 3 plus 3 over 2, and 6 plus 3 over 2. That simplifies to 0 and 9 halves. That's the midpoint. And so we have the midpoint. Now step 2 is to find the slope of the line that we're looking for. So first we have to find the slope of AB. Using B as the second point, we have 3 minus 6 over 3 minus negative 3. and we have negative 3 over 6, which is negative 1/2. Now we have to do the flipping thing again. We have to flip and change the sign. So the slope of the line perpendicular to AB, because we're looking for the line that is a perpendicular bisector, and we need the slope. So the slope of the of the line perpendicular to AB is just the opposite reciprocal. So we just flip it and it becomes 2. And now the fourth step, we just write the equation of the line. So we need the midpoint. So it's y minus 9/2 equals the slope we just found times x minus 0. And we got that point from up here. So we're done. That is the equation of that line. So why don't you take a screenshot of that, because you're going to do a problem just like that. Go ahead and try number 20. We want to find the equation of the perpendicular bisector of that segment, the equation of the line. So try number 20, and when you come back, we'll do it together. All right, we're back. First, we're going to find the midpoint of EF. That's 1 plus 0 over 2, and 3 plus negative 2 over 2. And that equals 1/2 and 1/2. So we have that midpoint. Now we need to find the slope, because we have a point on the line now. That's a point on the line. Now we need the slope of the line. So finding the slope of EF is going to help us find the slope we're looking for. So using F as the second point, we have negative 2 minus 3 over 0 minus 1. So that would be negative 5 over negative 1, which simplifies to 5. So we want a perpendicular bisector, so it's perpendicular, so we want the slope of the line that is perpendicular to EF, so we just flip that and change the sign, so it becomes negative 1/5. So now that we have a point on the perpendicular bisector and we have the slope of the perpendicular bisector, we can write the equation of the line, and we have to use that point, so 1/2, and the slope we just found, and that is the answer. So if you got that one right, again, we used this point, and we used this slope. So we got that answer. Good job. So now we're going to jump right into problems finding the circumcenter. So as you can imagine, we're going to find the perpendicular bisectors, two perpendicular bisectors, and we're going to find the intersection point. I'm going to find this perpendicular bisector, and I'm going to find this perpendicular bisector. And it looks like the perpendicular bisector is going to be right on the triangle. So we'll see what happens. So I'm going to say perpendicular bisector 1 and perpendicular bisector 2, so we don't get confused. So to find the perpendicular bisector number 1, I have to find the midpoint of AB. So 2 plus negative 2 over 2, and 3 plus 5 over 2. And we get 0 and 4. So now that's a point on the perpendicular bisector. Now we have to find the slope of the perpendicular bisector. So if we're going to find the slope of AB, using B as the second point, we have 5 minus 3 over 2 minus negative 2. And we get 2 over 4, which is 1/2. And now we have to find the slope of the line that's perpendicular to AB, and that's just going to be the opposite reciprocal, so it becomes -2. Opposite reciprocal of that. So now we're ready to write the equation of perpendicular bisector 1 using the midpoint as a point there. We have y minus 4 equals -2 times x minus 0. And there you go. So now we're going to find the equation of the line that contains, or whatever whatever you want to call it, perpendicular bisector 2. So step 1, we're going to find the midpoint. We need the midpoint of AC. So -2 plus 6 over 2, and 3 plus 1 over 2. And that equals 2 and 2. So now we have the midpoint. And now we're going to find the slope of AC, because that's going to help us find the slope we're looking for. Using C as the second point, we have 1 minus 3 and 6 minus -2. So we have -2 over 8, which is -1/4. So now the slope of the line that is perpendicular to AC, that's the slope we're looking for, so we flip and switch the sign and we get 4. And now finally the equation using the midpoint as our point, 4 times x minus 2. And that is our equation. And the good news is we don't have any fractions in those two equations. So now to find intersection points is going to be a lot easier. So I'm just rewriting those equations. And now, as usual, I'm going to isolate one of the equations, isolate y in one of the equations. And just rewrite the other equation. And now I'm going to take the equation where y is not solved for, and I'm going to rewrite that. But instead of y, I'm going to write what the top equation tells us y equals. So -2 times x minus 0 plus 4 minus 2 equals 4 times x minus 2. I want to move that over a little bit. So let's just double check this, make sure everything's right. Looks good. Now we're going to get rid of the parentheses. -2 times x is -2x. -2 times 0 is just 0. 4 times x is 4x. 4 times -2 is -8. And now we can just simplify. And doing the math, we end up with x is equal to 5/3. And to find y, we just use the equation where y is isolated. So y is equal to -2 times 5/3 minus 0 plus 4. And simplifying that, we get y is equal to 2/3. So the circumcenter is 5/3, 2/3. So the problem is very similar to the problems we've been doing before, as you can see. Let's see if that makes sense. 5/3, 2/3. 5/3, 2/3. 5/3 is approximately out to here. That sounds right. And then 2/3 would be about here. So that didn't quite work there. I probably just drew those lines a little off. All right, so why don't you try number 22. I'm going to use this perpendicular bisector, And this perpendicular bisector, if you want to work along with me, so I'm going to call this perpendicular bisector 1 and perpendicular bisector 2. So go ahead and try number 22. When you come back, we'll do it together. All right, we're back. So we have to find the midpoint of AC, and that equals -1 and -2. So let me just move that over a little bit. All right, now we have to find the slope of AC, because that's going to help us find the slope that we're actually looking for. Using C as a second point, we have 0 minus -4 over 3 minus -5. And that simplifies to 4 over 8, which is 1/2. And now we want to find the slope we're actually looking for, which is the slope of the line perpendicular to AC. So that equals the negative reciprocal. So we just flip 1/2, it becomes 2, and we change it to a negative. And finally, we can write the equation of the line we're looking for using the midpoint we found. We have y plus 2 is equal to the slope we just found times x plus 1. So that's the equation of the line containing perpendicular bisector 1. So now we're going to find the equation of the line that is perpendicular bisector 2. So step number 1, we're going to find the midpoint of AB. And that would be 0 plus -5 over 2. 1 plus -4 over 2. And that equals -5/2 and -3/2. So it looks like we can't really avoid fractions on this one. Step 2, we need to find the slope of AB. Using B as a second point, we have 1 minus -4 over 0 minus -5, which is 5 over 5, which is 1. Now step 3, we need to find the slope of the line perpendicular to AB, and that would just be -1. And finally, we can write the equation of the line that is the perpendicular bisector number 2. Using the midpoint, we have y plus 3/2 is equal to -x plus 5/2. And that is the equation of the perpendicular bisector number 2. So now we're going to find the intersection points. So we'll write the first equation and the second equation, and we're just going to solve it as usual. Take the equation where y is not solved for and rewrite it, but instead we're going to write what the top equation tells us y equals. Now we just have to solve that equation. We're going to get rid of the parentheses. We're going to combine all these numbers, and we get -5/2. All right, we have some good news there. We've got -5/2 on both sides of the equation. So it looks like we can just add 5/2 to both sides of the equation, get rid of those, and we end up with -2x is equal to -x. And so now we just add x to both sides of the equation, or we can add 2x to both sides of the equation, and we get x is equal to 0. because if you add 2x to this side, it just becomes 0. So now to find y, we use the equation where y is solved for. Y is equal to negative 2 times plug in 0 for x, so on and so forth, and we get y is equal to negative 4. So the circumcenter is 0, negative 4. So if you got that answer, good job. That was the hardest problem that you probably did today. Now we're just going to do 2 more quick, easy problems. We want to find the circumcenter of these triangles, but thankfully we have triangles with sides that are, one side is vertical and the other side is horizontal. So we can easily find the midpoints. The midpoint here would be right about there, and the midpoint here would be there. And the reason that these are easy is not just because we can easily find the midpoint, but the perpendicular bisectors, one is going to be vertical and the other is going to be horizontal. So we learned in a previous class that a vertical equation, this vertical equation would just be x equals 4. So that equation is x equals 4. And this equation is just y equals 3. Horizontal equations are y equals 3. So if y always has to be equal to 3 and x always has to be equal to 4, then obviously this intersection point of the perpendicular bisectors is just going to be that point there, which is 4, 3. So that's a real easy problem. The circumcenter is 4, 3. So why don't you go ahead and try 24, and when you come back, we'll do it together. All right, we're back. So we can see the midpoint easily, and we know it's the perpendicular bisector is a horizontal line. So that would be at 1, 2, 3, 4. Y equals 4 is this line. And we can see the midpoint easily here. And it's a vertical line because this is a horizontal. So that would be x equals negative 2. So obviously, if the perpendicular bisector is here and here, then they have to intersect at negative 2, 4. So the circumcenter is negative 2, 4. So if you got that answer, good job. So that was the class today. If you want to take screenshots of all the work that we did to help you with your homework or to study for tests, here's screenshot number 1, screenshot number 2, screenshot number 3, screenshot number 4, screenshot number 5, screenshot number 6, screenshot number 7, screenshot number 8, and screenshot number 9. All right, let's look at the homework. So this is the homework. Doesn't seem like there's much there. I only gave you 4 problems, but you have to find the circumcenter, orthocenter, and centroid for each of those problems. Be sure to do that homework completely and correctly. And remember, this is probably the hardest class of this course, so do your best. Be sure to put your homework in order in your binder, and I'll look forward to seeing you in the next class.